So, to respect in the time, আমরা আমাদের presentation deckটা শুরু করতে চাচ্ছি. I would like to request Sulav Kumar. Sulav Kumar is here. He's from SysDeck, and he will be presented. Sulav will be presented the topic Cloud Native Security 101, building block pattern and best practices. So I would like to Sulav start your presentation. Thank you.
Thank you, Amir. Hi, everyone. My name is Sulav. So we will have a session on Cloud Native Security 101. So this is going to be the basics of Cloud Native Security, nothing which is by diving deep into the technology. So I'm based in Bangalore. I work for Sysdig as a senior solutions engineer. So Sysdig as a team in India is not that big. We are only a few people, and then if you do not know about Sysdig, Sysdig is a cloud native tool which is responsible for security and monitoring of your Kubernetes and container environments. So if you have heard of Falco is something which was created by Sysdig, donated to CNCF, which has most of the downloads for runtime security. So we have a packed agenda today. So talking about cloud native security is like chasing 300 total in an IPL. So it is not possible to do in 30 minutes. But still, we will give it a shot and see how much we can cover. I had a couple of questions to ask you. Anyone here for the first time? But I know that everyone here is for the first time. First KCD in Dhaka. So I'll skip that. So you see a couple of acronyms or a couple of abbreviations on the screen. CWPP, CSPM, KSPM, CIEM, CNAP, CDR. Wanted to ask, is there anyone who knows all of them? Any two of them, three of them, any one of them? Okay, so these are the acronyms which we will be talking about in today's session. So these are quite important terms. CNAP is the latest one, so every time Gartner introduces these abbreviations or acronyms when they have to classify a tool which is for cloud native security, because it's a combination of so many things. So one abbreviation cannot cover it all. And the reason why we have so many acronyms is because the requirements of organizations differ. So they might sometimes just be on premises and not on cloud. So that's how these classification of tools differ. Okay, the packed agenda, we'll talk about the cloud native security acronyms and the anatomy of how the cloud native application looks like, application lifecycle, and then the platform building blocks of cloud native security. We'll also look into the attack vectors, which many of you will relate to, patterns and best practices, personas and workflows, which is where it targets all the teams which comprises of a DevSecOps team. Okay, so skipping to anatomy of cloud native application. The very first thing which you see here is data, workload, identity and access management, platform, network, and security. So on the bottom, you would see your cloud infrastructure. So this is talking about cloud native, but it can also be very well on premises as well. So you just have to relate on how this is going to be if you are on premises and not on public clouds. So when there is a cloud native application, you would see under workload, you have instance, containers, serverless. Most of the people are moving towards serverless. So when you say a workload, it can very well be your container image. And when you are securing a container image, it is not just the image which you have to secure in the cloud. It will be data where your databases comes into picture, like Cassandra or whatever. And then you also have your network and security, where you have to secure your load balancers, the IPs, virtual IPs, your audit logs, etc. And on the management level, you have your log tracking as well. So when you talk about cloud security, you would forward lots of events when it comes to threat detection to your tools like SIM, any of the SIM tools. So what you're doing with those logs in your SIM tool also comes into part of like cloud native application, because unless and until you look into the logs or you have something for detection and response, it does not make sense for a deployment as such. And then you have platforms. So how many of you guys have been using Kubernetes? Kubernetes and not Kubernetes, but non-containerized hosts like Linux hosts, you have your applications. I would say the VM world. Okay, okay. So the trend is to move away from the VMs to the Kubernetes, or to differentiate, you can just consider the VMs as non-containerized hosts, Kubernetes as a collection of containerized hosts. So keep in mind this differentiation, because this is where we will be talking more of the slides about. Yes, so let's get into the acronyms which we saw on the first slide. So the very first thing which you see here is CWPP, which is not the latest. It used to be about 6 months back, but now CWPP stands for Cloud Workload Protection Platform. So when it comes to workload, as we talked in the last slide, it is all about your workload scanning. So this is the layout which you saw in the last slide, but where CWPP comes into picture is only this. It will only secure your workloads. So you have your runtime containers, you have your images running in the containers. That is where you secure your workloads. When you are talking about securing workload, it includes runtime scanning, so that we show you that your workload consists of about 2,000 packages, and so many packages out of those 2,000 are vulnerable, and also how do you fix that. That's all about CWPP. So you can see that the rest of the components are left unsecured when you buy a CWPP tool. So CSPM, where CSPM comes into picture is everything except for workload protection, which is CWPP, and identity and access. So inside CSPM, it is just cloud security posture management. We would evaluate your resources and your inventory against certain benchmarks, which are set for, let's say, AWS has their own benchmarks, Google has their own benchmarks, Linux has their own benchmarks. So we will be evaluating your resources against those benchmarks and certain posture control, and showing you the results. That's what you classify a CSPM product as. So we looked into CWPP, we looked into CSPM. CWPP is runtime protection, runtime scanning. CSPM is cloud security posture management. Then comes the KSPM. So initially, when I talked about cloud and on-premises, so CSPM will basically be when you have a cloud deployment. But now let's say you have Kubernetes running in on-premises. So there is no concept of cloud there. So that is where KSPM comes into picture, Kubernetes Security Posture Management. There are a lot of tools which would do KSPM, because this is on-premises, you can integrate. Sysdig is one of them. So in the layout, you can see that this is the only section which comes under KSPM, and CSPM was as a whole. The next one is CIEM, Cloud Infrastructure Entitlement Management. It's a little confusing to differentiate between CSPM, which is a Cloud Security Posture Management, with CIEM, because anyone from a 10,000 feet view would say that a security posture management would also cover identity and access management, but not in reality. So there are tools which would do CSPM and not do identity and access management. So that is where the differentiation comes in. So whenever you are, so all of these acronyms are being talked about because if you are on your journey to migrate your applications into the cloud, or if you are adapting to Kubernetes and looking for a security tool, you have to decide what features you would want. And not many tool does all of them. I think, yeah, we'll come to that later, but whenever deciding for a tool, keep in mind if these are the things which you want and if these are the things which the tool covers, because somebody, a tool owner would say that they do CSPM, but they might not do CIEM. So for identity and access, you would still have to depend on the native tools. The next one is CDR, again, very important component, which is cloud detection and response. We also call it as threat detection. So this, you can see, covers almost everything, but does not give you the runtime scanning, which is where you get your CVEs or vulnerability management data from. This is all about threat detection for your workloads. So when I say threat detection, you might find some events saying that somebody logged into your container as a root user. So that's a security event, which is where the threat detection comes in. When it comes to cloud, whatever you are doing in your cloud environments, if it is something weird, which the tool understands can be a threat, those things will be shown out in CDR. The last one is CNAP. CNAP is the latest acronym by Gartner, G2, everything. They have classified a couple of tools, only I think 3 or 4 of them, if I'm not wrong, as a CNAP tool, Sysdig being one of it. CNAP covers everything. CNAP does workload protection. CNAP does CDR, which is threat detection. CNAP does CIEM, identity and access management, and of course the CWPP, which is not just the runtime workload protection, but also covers the whole life cycle of a cloud application. We'll get into the life cycle later. So we can look into the building blocks of CNAP. This is what I talked about, CSPM and KSPM, of course. If you do not have cloud and only on premises, that would be KSPM, CIEM, CWPP, CDR. Questions, if you have anything about any of the slides, you can just take a picture. We are right outside. We can discuss about that because the slide, the presentation is a longer one and too many things to do. So let's jump into the attack vectors. This is important when it comes to understand. We talked about the solutions. We talked about the abbreviations. We did not see what the problem is. Everyone knows what the problem we are trying to solve is. Problem is very simple. It's cloud security. But when you talk about cloud security, what do you classify as a risk? Or how your resources are risky and what exposes them? So we can talk about a couple of attack vectors here, like cloud network branches, unauthorized resource access. Most of these are self-explanatory. If you guys have been into any public cloud environment, you would understand what these are for. So any attacker can just target your identity. Let's say, even if I do not talk about an outside attacker, if you have a user who has excessive rights or controls, and their access is misconfigured, that again is a threat to your environment. Network, of course, everyone, I believe, would know the network threats which we have on premises and in cloud as well. When it comes to Kubernetes, the control plane again becomes something which can be classified as a risk. So rest of the things like cloud data exfiltration, cloud security misconfiguration, vulnerability exploits. When it comes to vulnerability, we'll go into that, but just to give you a one-liner, not all CVEs are exploitable, not all CVEs are critical. So it's a buzzword. Vulnerability management is a buzzword. Somebody tells you that your application has vulnerabilities. You don't have to panic because it might not be a panic situation at all. It might just be a false positive as well. So we will get into that later. When it comes to Kubernetes, these are the attack vectors. We talked about control plane, but that is only in the case of Kubernetes. So if you are going into or migrating towards Kubernetes, if you're going into that direction, you have to understand that these are the things inside a Kubernetes which can be prone to attacks, and that is the tool which you have to look for, which does everything for you. So access Kubernetes API servers have to be exposed. That is how you make the API requests. Even if you buy a security tool, it always has, let's say it is an agent-based tool. It will always have an agent, always have a backend. The communication has to be via APIs. Even in your environment, when you spin up a Kubernetes, it will be APIs, control plane, other components, the default components of a Kubernetes clusters. So it's quite vulnerable when it comes to the API accessing. Dashboard misconfigurations. Hopefully, people who have used Kubernetes, people who raised hands, they might have seen something very simple as a Minikube. So Minikube has a dashboard of its own. So understand that the Minikube dashboard is being accessed on a browser, right? And of course, there can be multiple misconfigurations when it comes to a dashboard. You might not be getting the insights which you are actually looking for. So those are the things which definitely comes as an attack vector. So whenever building the dashboards, you have to make sure that you get the insights, or you are using the right metrics, you are doing the right configurations, targeting the right resources. Malicious container image in registry, very important when it comes to build time and runtime security. So your containers might, your registry might have images downloaded from the web, from your developers, from your partners, from any source provider like Red Hat or whatever. You do not actually know what images you are downloading. So when it goes into your registry and you push it into a runtime, be it for a testing, I'm not saying it has to be a production environment, it is still risky because that image can be vulnerable. Application with applicable vulnerabilities, yeah, same thing. If your application has a CVE which is already out and the world is aware about it, there is no fix to that vulnerability yet. It is quite risky to run that application. So what you have to do is you have to circle back to your development team or the source where the image is coming from, stop that image from running in the container. It's a process, it's a whole cycle, but the problem comes when you do not know who to reach out to. And so now you have downloaded a Red Hat image and then the image is vulnerable, you would not reach out to Red Hat. I mean, they wouldn't bother. So there has to be a process which is in place to make sure that these are done correctly. And then gain access to the secrets. Of course, we talked about the secrets. On the right-hand side, you see how the control plane is prone to attacks. And the registry we talked about how the worker nodes are nothing, I think everyone knows, are the nodes in your Kubernetes clusters where the workloads would be running, which has a container runtime. Okay. And last is the Docker daemon misconfiguration, which is about downloading the Docker containers. So container workload attack vectors, we talked about Kubernetes. This is mostly about container. Whenever, I think everyone uses Docker when it comes to the container world. Vulnerable OS container engine, vulnerable application, exposed container engine, insecure image registry, privileged containers, misconfigured containers, privilege escalation on host, and insufficient network isolation. So whenever you are downloading a container, when it comes to container, you can imagine it about, if you talk about runtime container, you can imagine it as an image. What you are going to do with the image is run in your, on one of your nodes in your cluster. So on the right-hand side, it gives the same explanation that if an attacker has to attack, they would look into the kernel OS. Now, when it comes to kernel OS, every image has a base layer. So the target is always layered. So people would target the base layer first because most of the base layers which images would use are mostly public. You would not build a base layer by yourself. You would just export or import it from somewhere. Lastly, now you have downloaded a container, and then you are seeing that there are certain attack vectors with the containers. You have to push it to your image registry for your development team to use that, or for any other thing like pushing it to a pre-production, production environment. That has to make sure, it has to make sure that the attack vectors are taken care of. You have looked into all of these before pushing it. Okay, patterns and best practices. It might not always be your best practices, but we list it as best practices because that's what we see as a trend, and that's what we think should mitigate most of the risks which you guys would come across. Before we get into the patterns, let's look into the life cycle of cloud-native application. I'll not read through it, but it's quite simple. You have a code stage, you have a build stage, you have a runtime stage, and then you have you have a deploy stage, and then you have a runtime stage. So when you talk about DevOps as a whole, it is development plus operation. DevSecOps is development, security, operations. We come into the between, which is the security piece of it. Now, a developer might not care what the security team has to report back, but they will care after you report back, after you tell them that this is your image and it is vulnerable. So it creates a scenario within the development team that the image which we have built is vulnerable. So this is quite necessarily the life cycle of a cloud-native application. You code it, you build it. Provisioning can be different things, like you can provision it via CI/CD pipeline. All it matters in DevOps world is to have like continuous delivery of the applications or the versions of the applications. And obviously last is the runtime, which is the most important. At times you would also consider it to be the least important because you would not want your applications which are vulnerable to go into runtime at all. But even if it does, which it does, most often than not, your build time securities are overlooked and people mostly focus on the runtime security, but that's not the good way to go about it in future. You have to shift left And by shifting left, you can look at run and shift left, go towards code, build, provision, deploy, install your scanners everywhere. Yes, same thing like code, build, deploy, run, respond, and forensics. The last part is an addition on this slide. So when you know that there is a vulnerability or a threat when your applications or containers are running in runtime, what do you do? So you can report it back to your developer saying that these packages are vulnerable, fix it for us, then deploy it again. But if there is a threat which you see, like somebody logged into your container as a root user, you would want to see what it is doing and why it happened. That is where the incident response comes in. Capture details, record of forensics, block malicious containers processes. So Sysdig does that on its own. Like you get to see everything from system calls to the user ID, whoever has done whatever in your containers. Okay, most important, I would say, in the whole presentation of 30 minutes would be container in use vulnerabilities prioritization. So this is under runtime security for your running containers and running hosts. Important thing to note here is that it is applicable for your images and your hosts as well. When I say hosts, it can just be your VM. It can just be your Linux. When I say images, it will be the containers inside your VM or inside your Kubernetes nodes. Why this is important is because I think it might be safe to say that not many tools do this. Precisely only a few of them, one or two security tools would do this. You scan your images, you find that there are 100 critical vulnerabilities in your images. A developer, if I'm a developer, I would import 2,000 packages. Might not use all 2,000 packages. I would just use 200 of those packages for my application to be coded. When it goes into the runtime, all the 2,000 packages are scanned, pulled out of the metadata. And when we pull out all those 2,000 packages, obviously there are going to be more and more vulnerabilities associated with your image. So that's what I said in the starting. If your image is found vulnerable, it's not a state of panic. For the matter that it might also be something which you're not using at all. So out of the 2,000 packages, the developer might have used only 200. So we have seen that it's only 15% of vulnerabilities detected in an image which are in actual runtime. So if you see 100 vulnerabilities with your image, you can filter it down to only 15, which you have to fix immediately. So that's where the risk prioritization comes into picture. Multi-level vulnerability focus. So what we do is that firstly, we filter in use. So out of 100, only 15 are in use. How many of those 15 are exploitable? Maybe just 7 of them, half of it. How many of those 7 has a fix? Maybe just 2 of them. So you just have to fix 2 vulnerabilities and understand that your image is just running fine. So every tool would just give you a list of 100 CVEs, which you have to keep fixing. Your developer will push back because it's kind of very tiring work for them to fix all those 100 vulnerabilities. So you will free yourself and your developer team from that pain of going through fixing all the vulnerabilities at once. This is how it works, as I was talking about. So you have a container in your image registry that has 4 packages. 3 of them are vulnerable. When it comes to runtime, there is only 2 of those packages which are running, and 1 of them is vulnerable. So what do? That is the real risk. So this is the flow chart, if I have to say. This is how you identify it. Vulnerabilities in runtime, if it is in use, only then you move ahead. Are those which are in use exploitable? Only then you move ahead. Does those exploitable vulnerabilities have a fix? Only then you move ahead and fix immediately. If it does not have a fix, there's nothing anyone can do about it. So if a Red Hat image is vulnerable, does not have a fix on Red Hat, you have to wait for the fix to come out. Either whitelist that vulnerability or just do not use it. Throw it to your threat detection, threat mitigation team. They will take care of that. This is how you reduce it. The next is, after risk prioritization, image assigning is something which comes into picture. So if you have some images in your registry, what you do is that you associate an image signature with the registry. then push it to your QA registry. The QA verifies the signature, then you push it to the production. Only once we verify the signature in production, then only we release it to the runtime. Gatekeeper pattern is admission controller. AC stands for admission controller here. Very widely used, I would say, theory or technology. So it is based on Kubernetes admission controller. Now, what it does is that on the left-hand side, you see the 4 items which I have listed, like image scan status, image signing status, image container registry, repository, manage exceptions. All these 4 we have discussed before, like scan status gives you CVEs, signing status, you have to verify the signature. If all of these controls have passed, along with your exceptions as well, because you cannot have everything like taken care of, there always will be some exceptions. So once you take care of these, only then the admission controller will allow an application or an image to get into your node. So the right side, you see that if it has validated, then it sends a decision to Kubernetes API, only then it deploys the container to your node. If it does not validate properly, if it does not do that, then you just reject the image by getting into your container. Base image and layer analysis, we talked about this previously. So these are the best practices, we would say. We have developed a lot of labs internally for us as well, and that's where we see that using or starting with a minimal base image is the best. So in this particular example, we took an image from docker.io /node is the name of the image. You would find that on docker.io. It had about 15 critical, 153 high vulnerabilities. Now what we did is we just changed that image to docker.io node version slim, 18-buster slim. So using a slimmer version of an application gave us 1 critical vulnerabilities, which is 15 times less. 3 highs, which is about like, that's even less than 10% of it. So that's how you start with a minimal base image. These are the best practices because the attacks would always be based on the layers. These are the ones we are talking about. So you get an image from anywhere, maybe from your partner, you download it from internet. You can see the image A1.1 has so many 3 layers, and then image 2.5 is 2 layers, base image, and these have vulnerabilities. So what your security team would decide is that you should be using base image 1.2 because that also has all the layers and has no vulnerabilities. So the point which I'm trying to make here is that not every updated version will be the fixed version. So if your 1.1 is vulnerable, 1.2 may not just be the fixed version. It might be, or maybe 1.5 may not be the fixed version. It might be 1.2, an older version. So gone are the days when there were some bugs with your product. You update it to the next version, it fixes the problem. It is not the same with these images as of now. Continuous action, actionable compliance, continuous CSPM. We have seen these life cycle, code, build, deploy. This is where CSPM or KSPM, when it comes to Kubernetes, comes into picture. So along with cloud security or workload protection, you have to take care of the compliance as well. So whatever images you are using has to be compliant. If you are using a Linux image, it has to be something which is Linux compliant. If you are on AWS, it has to be AWS compliance. So also, you have to consider about IAC security, which is Internet as a Code. So you integrate your GitHub, GitLab, Bitbucket, these repositories with the security tool. And what that security tool would do is that whenever somebody is doing a merge request, we find out or evaluate it against a lot of benchmarks or security policies. If we understand that it is violating any compliance frameworks or policy, we directly open a pull request from the tool, goes to your team who is responsible for that repository. They evaluate the pull request, and then they send the merge request again. So it's a complete cycle where you make sure that your images or your development is compliant throughout the life cycle, from code time to the runtime. Risk assessment and prioritization. We talked about this risk assessment. and prioritization, like in-use came into picture. So I'll skip that. Personas and workflow. How many of you work in the DevOps team? DevOps, security, developer. Okay, very few developers. Okay, this talks about what personas a cloud security team should have, or we as a vendor, we always look into these personas. Like I would say that this guy is from the developer team, so he falls under this. And that's how we design the solution to everyone, so that it is based on your profile. A developer might not understand which everything is related to the security person. So a developer, platform engineer, DevOps, DevSecOps, security engineer, security architect, SecOps, this would depend organization to organization. Roles might overlap, roles might not match, but feel free to take a screenshot, decide for yourself which team you belong to. You might be designated as a DevOps engineer, but you might be doing security as well. So the last one is, of course, a CISO. We will not talk about a CISO. So we move ahead. Cloud security personas, this is where you fall. If you believe that you are a security architect, you are everywhere. If you are a security engineer, you come into picture after the image goes into runtime, or when you start talking about runtime scanning. SecOps is obviously the forensics and the incident response. Figure out for yourself where you belong. But this is what we understand it should be as per industry best practices. SecOps, DevSecOps workflow, CI/CD scan. So when I was talking about shifting left, we just do not have to concentrate on runtime scanning. We have to shift left towards build time as well. So you can see in this that consider a developer. Developer is pulling something from their secure repository, building an image using Jenkins. You might use any other CI/CD tool, but this example takes Jenkins into consideration. So we integrate with Jenkins as a phase within the CI/CD development itself. So it makes sure that your images, if found vulnerable while coding, does not move ahead, does not go into your registry. That's where you take care of the build time security. Then comes the registry scan. After a developer builds the pipeline, builds an image, codes an image, they have to send it to a registry. Now, when it goes into the registry, if exposed, the image is again vulnerable to certain exposures or exploits. So you can integrate your registry as well. So let's say you have any registry, Quay or whatever. So what you do is that you integrate it with the security tool, provide your credentials. So everything which you have in your registry gets evaluated every time. Regular scanning, regular evaluation, on-demand scanning, on-demand evaluation is present. So that's where you take care of the mid phase, which I would say is the registry scanning. Then the last one would be your, this is a step before the last one. Workload integrity, where we talk about the signature on the right-hand side. You saw how the container vulnerability in registry would look like. And then you have a set of private key, public key, which before moving into the runtime, it can verify the signatures based on this private and public key. Once the signature is verified, only then it moves ahead into production or your runtime container. If it does not get verified, we reject the image by getting into it. It goes back to the team who has pushed it to the registry, saying that this is not something, no, you have not signed it. We did not receive the signature or verified the signature. Please approve it again. Please sign it again. And then, this is the same thing which I was talking about, verifying signature using public and private key. The last one is admission controller. Second last one. Admission controller is the same thing. You verify your runtime deployment against certain policies and controls. If you understand that it has passed all those policies and exceptions, then you move ahead. You will have the capability to just make sure that you kill the containers, stop the containers, do whatever with this. Runtime scanning, much talks about this. Most important, only thing to note here is that once you have your runtime hosts and containers scanned, you can still send these as reports to your SIM and make use of your Jira ticketing tool integrations and everything else. IAC security, we talked about it. You integrate GitLab, GitHub, Bitbucket, open a pull request directly. It goes to the team managing the pipeline. The runtime phase IAC security is where you detect a drift. You report it using a pull request. The drift policies comes into picture. It gets taken care of. Only then it goes into your working nodes. OK, I think that's it. So sorry, I rushed through the last few slides. Yes, any questions, anyone's? Few takeaways are listed here. There are further reading options. You can take a screenshot, but we are right outside, so you can make use of these. Any questions?
Questions? Yeah.
Thank you. So basically, it was a very good presentation, insightful. So my question is, we have observed in some of the security solutions, like I'll not take the name, but when we scan the container image, it creates some problem in terms of resource utilization. Do we have any capping mechanism that it will not go beyond that limit?
Yes. So I'll, as you did not take the name of the tool, I would talk about something which we have. Now we have agentless solutions as well, agent-based solutions as well. I'm thinking the scenario you're talking about is agent-based. Now in agent-based, when you're deploying using Helm or you're deploying using YAML, we can obviously limit it to the resources, your CPU memory resources. With Sysdig, there is something called as Slim, Agent Slim version. So that only gives you the capability of limiting your resources by not utilizing most of the things, because the agent is supposed to be doing hundreds of things. You might not need all those hundreds of things. So that can help you limit those resources of memory and CPU. Any more questions?
Any questions? Then we will end up. So,
thank you.
Thank you, Sulav bhai, for your nice presentations. I must say it is good. Thank you, Sulav bhai.